here we go. Okay, anytime.
Great. Thanks, Devin. Thanks for having me. Basically, yeah, I'm Wynand Groenewald. I'm an independent consultant specializing on naturals for retail industrial applications. Also, basically looking at around cold chain sustainability and how we can improve processing facilities, cold storage facilities, not by just looking at the refrigeration equipment, which is important, but also at how to put these systems together and how can we look and take an holistic approach at these facilities. So basically, I'm based in South Africa, but have been and is currently working around the globe. So I'm involved in the USA and Australia, and obviously the rest of Africa. So there's a lot that I'm learning also as I'm going, and I would love to share that, and I would love to see it going ahead. So without further ado, I'll get into my presentation, which is basically I just went into too much technical details, just a little bit of thought sharing on what can be done or what the impact is of a cold storage facility, and how I do see or feel that we can tackle cold chain to make it sustainable and grow the industry. So basically, first looking at cold chain. So question firstly is probably, what is the goal of cold chain? So cold chain is in the word, it is a temperature controlled supply chain. So basically the reason for having a cold chain is to preserve, extend and store products. And these products can be meat, frozen food, medicals, fruit and vegetables, basically anything that needs to require. The reason for the cold chain is it plays a role in preserving and extending the shelf life of these products, and thus creating food security and reducing food waste. Looking at reducing food waste, it is a massive problem, and also a problem that needs to be looked at from a greenhouse gas emission point of view. I did a bit of research, I did a bit of looking up, and currently in Manila alone, there's about 2,000 tons of food wasted every day. And that's definitely something that a cold chain and good management of a cold chain can reduce. As I mentioned before, there's obviously then the increase of food security around the proper cold chain. Cold chain is everything farm to fork. So basically, once the product gets taken off the land and until it ends up in your home fridge is considered a cold chain. I think this creates a lot of opportunities, a lot of industries, and especially developing countries where these cold chain facilities are not properly implemented, or there's still a lack of cold chain facilities. I see it as a benefit. There's a blank canvas to start working on to improve and to have an immediate and to plan your cold chain facilities to be as sustainable as possible. For instance, cold chain is not just only large storage facilities and large processing facilities. One way that we can look at is to decentralize the cold chain, move it closer to the farms, leading to a reduction of the requirement of transport to move these produce. So that can also then be much smaller facilities that is required, which is easier to implement, and it's also at the end of the day easier to basically take off the grid once it's required to do so. A small facility is much easier to run off solar power or any other renewable power than it is to do with a massive or large facility. And the benefit that's always also around taking a decentralized approach on cold chain is the work creation that's involved with it. A lot of developing countries are continuously looking at improving the status of job creation and the availability of work within the country, and cold chain can really play a large role in that, and not just reducing greenhouse gas emissions. So when we look at a sustainable cold chain, there's a lot of aspects that can be looked at it. In a nutshell, basically, you would like to have a cold chain facility that's environmentally benign, doesn't have a negative impact on the environment. So one large thing that needs to be done around that is to look at reducing the reliance of grid power, or ultimately the independence of grid power. So as I mentioned earlier, smaller facilities, decentralized facilities might be a step closer to really get these to run off renewable powers. Also an holistic approach. A lot of facilities look at refrigeration as only one aspect of it, and then someone else will look at the heating requirement, and someone else will look at the air conditioning requirement, chilled water requirement, any other heating requirement or cleaning requirements. So at the end of the day, I think what's really important with a sustainable cold chain is to look at an holistic approach in incorporating all of these cooling and heating requirements at different levels and utilizing them with each other to get the benefit, instead of having decentralized systems within a facility all doing a small little part of either heating or cooling. That can also be like the recycling of condensate water. That's one step that can be looked at. Water is generated through the evaporators within the facility. Usually that water goes to waste, where that can be incorporated back into the facility, either for use on the refrigeration side in terms of adiabatic to reduce the energy efficiency of the refrigeration system, or overall irrigating gardens or washing up, and that can just really have a positive impact on the environment as well. Basically, a sustainable cold chain, at the end of the day, you want to reduce the operational cost. So there's alternatively, other than looking at sustainable or energy efficient refrigeration equipment, there's also storage. There's also a approach that can be taken to look at either thermal storages, which will lead to a peak demand reduction. So you can basically shift your cooling, create your cooling when you're out of your peak load and peak demand reduction, and then basically utilize that stored cooling or heat when it is required in high peak demands. Basically, reducing operational costs basically means that at the end of the day, you are using less power. Using less power means you are emitting less CO2 into the atmosphere. Basically, roughly, if you look at a coal-powered facility, you're looking for every kilowatt hour produced, it's about 1 kilogram of CO2 being emitted into the environment. The other aspect that's also sometimes not seen or not looked into is that the water that is required as well with these basically coal-fired power stations, where up to 3-4 liters of water is required for every kilowatt of hour that's produced. So at the end of the day, a sustainable cold chain is to reduce your power consumption as much as possible so that you can save water and basically reduce the greenhouse gas emissions of a facility. So the impact that a facility can have, basically the general and overall measurement of a facility's impact is the so-called total equivalent warming impact. So the TEWI looks at two aspects when comparing or looking at the refrigeration system. So firstly, it's the direct emissions, which is due to refrigerant leakages, and then the indirect emissions, which is, as I mentioned before, the CO2 emitted into the atmosphere by consuming the power, and by consuming the power, that power needs to be generated. So basically just took a kind of a small case study. This is based on a facility that I have done, so I think it's quite decent information, and it was basically vetted information. So initially, the baseline system was a 404A system, and then looking at the direct and indirect emissions of this facility that was running on R404A as a refrigerant, the direct emissions over a yearly period came up to about 6,395 tons of CO2. This comes from looking at the GWP factor of a refrigerant and then the amount of refrigerant that is lost and leaked out throughout the year. And that basically amounted to that amount of tonnage that we can see. Indirect, then the amount of power consumption. So basically the amount of power consumed by that facility at the end of the day had the effect of having 10,500 tons of CO2 being emitted into the atmosphere. So taking the same facility and looking at a different approach, again looking at the TEWI of what can be achieved on a yearly impact for a single facility. Step number one, obviously, was to look at implementing a natural refrigerant. By implementing a natural refrigerant, immediately your greenhouse gas emissions due to refrigerant leakages became zero. So what was seen in the initial facility being emitted as a CO2 equivalent into the atmosphere has now been reduced to zero. Basically achieving a 30% energy saving alone on the facility meant a further reduction of CO2 emissions from the indirect portion. And basically comparing the two situations or the two facilities directly with each other, a 56% reduction already in greenhouse gas emissions can be achieved by just taking a different step or utilizing an efficient natural refrigeration system. And there is still plenty more to do. I mean, this has been 30% energy saving has been showed and achieved over and over throughout these facilities. And even depending on the technology that's used and even an older type of technology, that energy saving can be even much higher. So then basically as came down from what I said, one large aspect within the CO2 emissions related to a cold chain facility is the refrigerants. So basically one of the first decisions that needs to be made is what type of refrigerant needs to be used. Currently, one of the reasons, and this is not just environmentally, but also from, I see it from a investment point of view, what is the smart choice to do, according to my opinion, looking at what currently is happening with a global phase out of HFC and HFC-based refrigerants. With the Montreal Protocol, the Kigali Amendment to it, and the Paris Agreement, there is a massive and a strong move towards refrigerants with a global warming potential of lower than 150. Basically, this takes out all current solutions or all refrigerants that has been used up until date and has been used over the last 30-odd years. So basically, this comes down to naturals as an option. And the reason why I say is like why you need to look at it now is any facility that gets implemented today has at least an expected plant life of 20 years. So these, I get a lot of questions asked, but we're not going to see stringent phase out or tax regulations or regulatory obligations within our country in the next 5 years. But you putting a facility down that you want to last for 20 years. So why do you only want to, when it gets to the obligatory part of it, have to change in 5 years before it's much less before it's at its end of life? So basically, my opinion currently is that there is no future for conventional refrigerants at this moment. So our options currently that we are left with is ammonia, CO2, hydrocarbons, water, and oxygen, or a combination of them. A lot of great facilities has been done with a combination of ammonia and CO2, small hydrocarbons introduction as well into the facility. And this comes down to what I said earlier, is how do you implement all your requirements of heating and cooling into a system that is really achieving a lot of sustainability. The benefit of these refrigerants, there's no environmental impact. It's really a future-proof and sustainable solution. So what you invest in today will last you till the end of the life. They are energy efficient, and also a misconception is that there is currently available a solution for every requirement. From small capacity to large industrial facilities, there is a natural solution that fits every requirement. Basically, also just looking at a lot of headway being made with low GWP alternatives. So I just wanted to touch on this as well, because we get a lot of the questions asked, like, should we leapfrog or must we weigh ourselves into and then later go to naturals? Basically, so HFOs is refrigerants that's currently being utilized as low GWP alternatives. The thing is, just with HFOs, there's really only actually two real HFOs, which is 1234YF and 1234ZE. The low GWP alternatives that's on the market is blends. So they are these HFO blends, the 1234s, mixed with HFC refrigerants, which at the end of the day give you a reduction in your global warming potential. But the reality is that, for instance, if I just took a random low GWP refrigerant, which is R448A, at the end of the day, the mixture and the blend of that refrigerant is still 72% HFCs, and only 28% of that refrigerant is made up of HFO. And even at the end of the day, basically, your GWP of the R448A is still very close to the GWP value of, for instance, 134A. And again, as I said earlier, is you're still buying an HFC, so no one knows when these HFCs will become either really expensive or even banned in making blends. And a different way that I also would like to look at GWP values is to look at them at 20 years instead of a 100-year period. So the GWP values of refrigerants that we are all known to and that we hear on a daily basis is all measured over the impact it has on 100 years. Firstly, your facility is not lasting 100 years. And secondly, the goals and the impact reduction that we need to have on the environment is by 2050. So that is 30 years from now. So you need to look at a reduced impact that these refrigerants has. Basically, the impact is quite significant because 134A, for instance, over 100 years, the GWP factor connected to that refrigerant is 1,300. If you look at the GWP and the effect it will have on a 20-year period, the GWP value becomes 3,710, which is quite a large and significant jump from where we are known to about these. Also around the HFOs, refrigerants, there's currently a lot of concerns about TFAs and long-term environmental impacts. And I've recently read up about someone writing a document or a document that was published stating that there's too much uncertainty about the regulatory movements and how strong it's going to become in the next few years, that it is not seen as a feasible investment towards low GWP refrigerants. Then another thing about natural refrigerants. So basically, I think this is my experience, and what I would just like to put out there a bit around naturals is what I would like to think is myths. And I hope I can be proven right by a lot of other people as well, but basically stating that natural refrigerants are dangerous. Natural refrigerants obviously really are not dangerous. A lot of them are not flammable or non-toxic. And then really the ones that are flammable and are toxic are at low levels, and a lot of safety measures are around these technologies. Naturals has been used extensively over multiple years, and there has always been a lot of improvement around the safety. So definitely, in my opinion, not dangerous to use natural refrigerants. Said to be a new technology. Basically, I think over the last 20 years to 30 years, naturals has been progressing, and a lot of R&D has been going into naturals. So currently where we are today, it's not a new technology. There's multiple vendors, OEMs, training facilities around the globe, and in a lot of different countries and even developing countries, where these technologies are freely available and used. Superior skills, sometimes everybody feels like that's something that you require. My opinion with that is, like, refrigeration at the end of the day works in a similar manner. There's like the differences between using a certain HFC versus another HFC that you need to learn and get used to is the same with the naturals. At the end of the day, the principles of refrigeration apply. So if you know how a refrigeration system works, you definitely do have the skills, and with training towards just understanding the natural operating envelopes and properties of these refrigerants is all that is required, basically, to upskill yourself to be able to use naturals as a refrigerant. Also, the feasibility of some natural refrigerants within high ambient conditions, because I think the Philippines also would be considered as a high ambient region. Basically, for me, the depiction of high ambient is really like the 40 degrees Celsius and up, where with the Philippines falls quite well below the 40 degrees Celsius, having a nice, very mild and moderate temperature of 23 to 32 degrees Celsius, and it does not vary a lot over the year. That benefits you as well in the designing of the system. You don't have extreme colds and extreme hot conditions. You have a fairly moderate temperature throughout the year, which can, if you do really design around this, can lead to more efficient systems and well-designed systems that's not over or undersized. There's a lot of summer rain, which at the end of the day basically becomes your own adiabatic condenser. So rain and humidity all leads to good heat transfer and good basically rejection of your heat in condensers. So this all basically leads more to the benefit of refrigeration systems than the detrimental side of it. Then stating that also a lot of people state that it's expensive. There is some, like, it can be a little bit more expensive than other refrigerants. But what I have found over the last few years is that naturals has really maintained their level of cost and hasn't gone up a lot year to year, whereas HFC or HFC-based refrigerants and technologies has gone up incrementally. This is due to taxations and legislations around the world that you really are starting to see spikes in the cost of these systems, and where there's a reduction or a stability in the cost of natural systems. That is due because it's supply demand. The more of these systems are being used, the lower the cost will become. Inefficient. At the end of the day, it's been proven multiple times over and over that natural refrigeration and natural solutions really can be efficient. That also comes, I think, into the expensive part of it, is when everybody looks at utilizing natural refrigerants, it's being utilized to be as efficient as possible. So sometimes also the cost comparison between a natural solution and a non-natural solution is not apples with apples, because a lot of measurements and a lot of additionals has gone into these natural solutions to make it as efficient as possible. So just basically looking a little bit more into clean cooling. So as I said before, there's a lot of steps and as I mentioned, reductions and savings of up to 56% in the greenhouse gas emissions that can be achieved just by looking at alternative natural refrigerant solutions and having as efficient and energy efficient systems as possible can really show a massive reduction already in the greenhouse gas emissions, and obviously then the sustainability of a cold chain or a cold chain facility. I think one thing that does get overseen a lot is that the focus should not just only be on the system and the refrigeration equipment itself. There is not enough emphasis put into the facility and the optimizing of a facility. Basically, my opinion is, and I strongly feel that refrigeration should be looked at from the beginning of the development and implementing stages and design of a cold chain facility, or whether it's processing facility or a cold storage facility. Basically, I think what can be done there is the benefits you can get with really thinking and optimizing a facility is that you can already reduce the cooling requirement. Just having a facility that's better laid out and better put together and well thought out, the orientation of the facility can already reduce the cooling requirement. There's a lot of natural resources available that sometimes just get forgotten or doesn't even get thought of being implemented or utilized within or around the facility. So that definitely also needs to be looked at. From day one, designing a facility to be enabled to incorporate all your heating and cooling requirements, from hot water to air conditioning, on top of the freezer or the cold storage facility. Also investigate and incorporate your waste resources. Like a lot of systems in processing facilities gives off heat or gives off cooling. And that just gets either dumped into air or to water and moved away from the facility, where that all can be used back into the facility. Also management to reduce the cooling demand. When you supply, how you supply, how you stock your facility, how do you manage your facility and the people moving in and out of your facility really can reduce your cooling demand significantly. Facility layout and plant layout. A simple thing as a plant layout, it's an actual project that I've been involved in, where at the end of the day, we basically actually didn't have an opportunity, but the refrigeration equipment, including the condensers, for instance, had to be in the parking facility. What was found at the end of the day is that with the condensers being in the parking facility, it was shaded and it wasn't in the sun, and it had a cool atmosphere basically all year round. And that specific store basically had an additional 20% energy reduction compared to similar stores where the condensers had to be standing outside in the sun. So basically just making sure that your condenser is not facing the sun the whole day, has a significant sufficient amount of airflow across it, already really has a significant reduction of your energy consumption. And then optimum insulation and isolation. As I said, your facility is there to cool the product that goes in there. It's not there to cool the whole earth. So basically, isolating and having your facility well insulated and well managed, ensure that the power that you put into your refrigeration equipment is directly going to your product and it's not being wasted and leaking out. Basically also, if you're in the beginning looking at these phases and getting involved, you can look at energy storage, you can incorporate that. You can have all of this laid out and deciding and do the cost feasibilities and have all of this implemented. Another thing as well is obviously to optimize the supply chain. If you have food coming to your facility at a temperature already close to its requirement, it obviously takes a lot of load off of your facility. So this, at the end of the day, is everything that just doesn't have to need to be assumed or taken as for granted or is how it is. That can really, if that gets looked at properly, a massive reduction in your requirement of cooling already can be achieved, which then leads to the next facility. So, or the next implementation is basically this. At the end, so basically refrigeration equipment suppliers or contractors or designers will get pulled into a facility once it has been laid out and approved and going ahead. And then basically then you need to put down a refrigeration system to take care of the requirement. But by taking those first steps, when you then get to a point where you're looking at the refrigeration system, you have optimized cooling equipment already, because you can really design with a lot less of assumptions made around the refrigeration requirement and capabilities. Obviously, there's a reduction in cost of the required cooling system as well, because you are only putting a system down that needs to do what it has to do. And also what has to be done is a lot less. Your capacity reduction will then lead to a cost saving in your refrigeration plant that is required at the end of the day. Incorporating cooling systems with lowest impact on the environment then is obviously also then a better solution to further reduce your greenhouse gas emissions. Having then no additional heating and cooling equipment, if you have been able to implement and put them all together and take care of your waste and cooling, then definitely there is already a massive reduction in the facilities required to do the additional heating and cooling at the end of the day. And then obviously make use of efficient natural cooling equipment. But as I said, the benefit you have then is you might have a 60% smaller refrigeration requirement. You do not need a heat pump or a electrical boiler to do heating for you. It's already been incorporated into your facility. That then already, without looking at a facility or looking at a plant that is as energy efficient as possible, you have a massive operational cost saving already by just reducing your cooling requirement. It then would be easier and more cost effective to incorporate renewable energy into a facility such as this. I mean, a 1 megawatt cooling facility needs a lot more solar panels or a lot more renewable energy than a facility where the cooling demand has been reduced to 600 kilowatts. And then, as we said, at the end of the day, reducing the power consumption basically reduces your greenhouse gas emissions. So by having a reduced cooling requirement leads to using less energy and then emitting less greenhouse gas emissions into the environment. And then ultimately a continuous management of your facility. Basically an unmanaged and unserviced and maintained refrigeration plant can lose about 10 to 15% of its efficiency within 5 years of operating. So continuously just incorporating maintenance and management of your facility also leads to a massive reduction of your power consumption. Then just touching basically on, I think, summing up what I was referring to in the last 2 slides, is that I honestly and really feel that cooling today is not an afterthought where a system has been designed or a facility has been designed and the requirement is for X amount of cooling. By really taking an innovative and holistic approach from day one can reduce your requirements for your cooling. And this can lead to a lot of saving of money from day one, reducing your demand and having an optimized refrigeration system at the end of the day. Thanks for your time. I hope it was at least a little bit of use. And thank you for listening.